In this tutorial, I'll show you how AutoVision machine vision software can be used to check information printed on labels or marked directly onto packages. In this particular case, we'll take a look at a product that contains several pieces of laser-marked information. There are two barcodes, one UPC EAN symbol for point of sales, and one symbol containing the lot code. The same lot code is also presented in the human-readable form below it, and next to a lot code symbol here. At the top right side of the package, there is some additional information including an expiration date. AutoVision can be used to check all the pieces of information on this package. Let's have a look at the program that I've already prepared for the VisionHawk Smart Camera. You can find the program here at the left side of the screen. In the center of the screen, you can see the image. The blue boxes are the tools that I've already inserted. At the right side of the screen, you can find the parameters belonging to the tools on the left side. At the top of the screen, you can see all the tools that are available in AutoVision. The first step in every machine vision job is to capture an image, or take a picture. In this particular job, the next thing we'll do is read the lot barcode. The lot barcode data is shown here, in the tool, and you can see that the read was successful. The tool also returns a position, and this position is used to locate other subsequent tools. For example, the optical character recognition, or OCR tool here. This one is positioned underneath the barcode, and it reads the human-readable text. AutoVision's OCR tool can be trained on any font by simply entering the characters and adding samples. The next step is to ensure that the data contained in the barcode matches the data printed in the human-readable text. AutoVision can do that by using a match string function that compares the two strings from the decode tool and the OCR tool. If the two are identical, the tool passes, as in this case, and we can be sure that the two pieces of information are identical. The next step is to verify whether or not all the information at the top right corner of the package has been printed correctly. AutoVision can do that with the Optical Character Verification, or OCV tool here. The OCV tool works with a pre-trained template that's automatically trained on each symbol in the text. The OCV tool will compare a trained symbol against the same symbol in the same position in the current image. If there are any differences, AutoVision knows that the character has been printed differently. If the difference becomes too big, the character can be rejected. This way, we can be assured that no product containing poor or incorrect printed text will be shipped. We can use the same technique for the lot code symbol. Again, the entire lot code symbol is trained as a single symbol and can be compared on each subsequent read. The next step is to check the angle of the label, or in this case, the package. With the angle tool, we can measure the angle of a label, and by setting the normal angle plus a tolerance, we can be sure that the label is always aligned on the product. If not, the product will be rejected. Last but not least, let's look at AutoVision's ability to check the quality of printed barcodes to known standards. In this case, we're checking the quality of the 1D symbol, the lot code, using the ISO 15416 standard. If we click the barcode here, we can see what the tool has actually measured. It has taken 10 measurements across the height of the code. As you can see, this particular code has an issue with the quiet zone, the area right and left of the symbol. There is quite a bit of dirt in the symbol, and that's why it's failing on the quiet zone. Additionally, there is some poor modulation that's probably due to the defects in this area. This code would be rejected per the ISO standard, but if you have a production process where you decide that the quality of this symbol is good enough to be used throughout the factory, you have the ability to adapt, pass, or reject the verification tool to what your production process calls for. You can do that by selecting Custom Verification and enabling it. With Custom Verification, you have the ability to decide what the pass-fail level should be for each parameter, as well as the ability to exclude certain parameters from the final grade. In this case, I have disabled the quiet zone. If I select this, you can see that the tool now has a grade C, based on the lowest value of the final grade. Once you exclude certain parameters from the final grade, the measurement no longer adheres to the ISO standard, but the tool can be used to ensure consistent print quality from the laser marker. The final step in any program is to report the results to the outside world. In AutoVision, the inspection outputs allow you to use digital outputs, for example, to send the results to a PLC system. In this case, output 1 is used to signal when the inspection passes, and output 2 signals that the inspection is completed. So output 1 is valid. In addition to digital outputs, there are also RS-232 and TCP/IP serial outputs that can be used to report information from the machine vision program to an outside system. In this case, I've set up a message that returns the results of this inspection, being the decoded barcode, the verified grade, the OCR code, and the status of both the OCV and edge angle tools. After completing a program, you can go into run mode. The program is then copied into the camera and saved in the flash memory. And the camera can run with AutoVision and work like a barcode reader where it's taking images, qualifies them, and based on the output, the product can be approved or rejected. AutoVision does not need to be running to achieve that. This is what the run mode looks like. We can see the same tools that we saw in setup mode. They're all passing right now, but if we were to create some problems, you can see the tools failing and the product being rejected. Thanks for watching. If you'd like to view more AutoVision tutorials, please visit our website.